please do grab a copy of the files down below. It's completely free and modifiable. I put it under the GPL license, so you can do that. All you do need is a bow, rosin, and strings, and I do recommend heavily following the printing and optimizing instructions, because these can be a little finicky, but if you can do that, it does work.
Okay, so here it is to take a nice look at it. Not too bad. Could be improved in the looks department, but functionality was the main idea, and there are some slight issues, but it does work pretty well for what it is.
Okay, so here is the final design. It only took me like a few hours really to make, and then it took me probably a couple more hours to fix up a lot of issues. Now, first thing you might notice is that I had to split it up into usually about 16 by 16 centimeters is the largest you really want to do for 3D printing. You can get things up to about 20 to even 22 centimeters on a standard printer, but you don't really want to go beyond that. Once you start going beyond 18, things get a little bit wonky. This is probably about 18, give or take. So you see, basically I've split it up into three main parts: the bottom part here, the middle part, the neck, excuse me, actually four, and the head, at least lengthways. And now the tuning pegs are, so we have 4 tuning pegs. These are just standard. They have a hole in them. You know, these can actually be used for standard violins as well. And the head is really nothing fancy. It's just the head is just it's basically a box with a long connecting piece. So if we move the head, we can also see the fretboard is basically just a raised, curved thing, and then it's got the connector here, and it's got like circle-like connectors, which are pretty nice, which connects into the neck. And the neck is similar to the head. It's got a square connector. This one you'll have to sand a fair bit, and it's just got holes and a square intake as well. This is a little thick. If your hands are too small, you know, do message me and I will make a smaller fret, assuming a smaller neck to help you out. And then, for example, if we look at the top is just, it's got a hole in there, and this is the female connector, and we can see it's a little thick. It's like almost 4 to 5 mil thick, which is way thicker than a regular violin. I made it thick because I wanted it to be stable and survive. It completely negates the resonance, which is kind of annoying. But the other issue with the resonance, which we will see, is that the F hole is in the lower part of the body, when usually the F holes are around here and here. So you'll see the bridge is it's a bit lower, but this is usually where the bridge would be, and the F holes will be kind of side and side on. And the reason I had to do that, of course, is because I have to break it up into multiple sections. Now that makes it a lot quieter, which is, I guess, you know, not as professional, but I don't really mind because it works just fine. We do have a what do you call it? I forget what they call these things, but they're usually meant to go around to the right side here, kind of underneath or around here, around under the bridge, but I changed it up. And then there's a hole for the traditionally there's like a back hole for the fin, but I was gonna do that, and I just didn't think it would be sturdy enough. The fin is actually incredibly sturdy as long as you fully print it. And then, of course, we have some pretty standard looking string holding holes, which work really well. There's no fine tuners, unfortunately, but as long as you sand and rosin the pegs, you don't really need fine tuners. Then we have a little chin rest. Again, if you want it removed, just tell me and I can remove it for the model. So that's the base. And then finally our our bridge. Actually, this is a earlier model. I've made these a little more curved so you can see, because that's a vulnerability how small that is. But they call this the heart and they call these the kidneys actually, which is really interesting. Maybe that's the well, you could figure that part out. I had a lot of trouble with the bridge actually. I'd like continuously I had to keep remaking it, but finally I've found something that works fine. Actually, this isn't the final bridge. This is actually the final bridge, because what I had to do, yeah, the mesh is terrible. That's because it's an SDL. I had to raise these top areas here, because when you're bowing, if this is too low, it will basically make you play this other string as well, and this string, like the G and the D, assuming the G and the A, which is really annoying because you got to think like, you know, the angle of the bow. You can see here I had to sand it a fair bit to get it to fit, and now I will push it in. Okay, now this is essentially how you want to print everything. So for the base, the way that I did it, because it's super thick, I just printed it this way, and then I printed it with supports. So that's fine. You can print it solid. By the way, I'm using Orca Slicer, which I heavily recommend. You can print it 100% if you want, but honestly, it's pretty strong. I think that connector and the rod sound post is pretty strong. Potentially, you could try to do something like that as well. I'm not sure. Otherwise, if you do something like this, it's probably gonna have supports everywhere and it's gonna be horrible, so I wouldn't recommend that. Then the exact same thing for this. I personally, the way I printed it was just like that, and again with supports. The only reason you need supports is for that bottom part. The rest of it should be fine. I had supports in kind of in the side areas, which are a pain to remove, but I don't think it really needed it. Now the fin, it's very important that you do 100% infill for the fin, because it needs to be super strong. Mind you, this is all I'm using PLA for everything because I specifically wanted it to be easy for people. And then I just printed it kind of on its side. But I also wanted it to be on a weird angle. So anything with a connector, you want to be kind of on a bit of a weird angle. The reason why, when we slice it, here, I'll show you. When you slice it, you can see the grain pattern is kind of weird. It's like this is straight, but it's technically, you know, here it's like that. You can see it's kind of like that makes it very, very strong. So this rod will not rip off with this kind of grain pattern. And I personally did use supports for this. They're a bit of a pain to get rid of, but they, you know, if it gives you a better result, then good. Next, for the bridge, all you need to do for this is just to lay it flat, as flat as you can, either side. It really does not matter. And then you just need to do 100% infill on the bridge, because it needs to be solid. Even though, you know, usual wooden bridges, the wood pattern is, I think it goes down. It's meant to. I've seen ones that go sideways. I guess technically they're wrong, whatever, but it's too weak if you do it that way. The next is the neck. This one, I'm pretty sure I just did it like that. And then, of course, you'll need supports for the neck. And I recommend anything with a connector or an internal area to print it, again, 100% infill. Now the fretboard, this is pretty much the only one you don't really need to do 100% infill. It seems fine enough. All you need to do is just print it on its side, and then it says over the boundary. So what we need to do is we need to turn it. You can see how when we rotate it, it's no longer along the boundary. It's fine now, so that will print just fine. And I recommend supports as well because of the little pegs. Now is the head. Now this one is pretty easy. It's the same way. If you click this tool, lay on face, and you just click one of the faces. I just did it like that, and I did it with supports. And again, I recommend you do 100% infill because it has a connector piece. Now the connector piece is on a weird angle, which means again it will print a little bit more strongly, while if you just say had this shooting up in the air, the grain pattern would make it a lot weaker. So this should be just fine. And as we can see, yeah, like that, it's kind of a bit, it's like a weird grain pattern, which makes it super strong. Which is what we want, because again, this is all like I'm doing this so we can actually have it with PLA. And then with these, you just want to go same thing, lay it on one of its faces down there. You want the hole sticking up, and you can use supports, and you can also use 100% infill again, and then this should be just fine. And you want to print 4 of these, of course. Now you can see there's a little bit of, there's a tiny little hole of support down there. You'll just have to get a piece of like some pliers, some like snippers, and then chop it off. And you have to sand and rosin these, by the way. You'll have to sand a lot of the connectors, and I would recommend rosining them as well, if you just for grit or like talcum powder. But otherwise, if you got the rosin, you just rub your bow against these once you've sanded them nicely, and they will work just fine. Again, you want the hole up so you don't have to poke anything through it. Otherwise, if you have something to poke through, then you can print it a different orientation, but otherwise I don't have that.
To show you how this actually works, so I figure it's pretty obvious, but you just push it in, and then you just get it here, oops, excuse me, get it in there, so it's like locked in. There you go, it's locked in like so. So that's good. And then, if you don't know how to turn, let's do this. You just go all the way down here, get the sharp end, stick it properly in.
I recommend for the 2 thick strings to wind them under actually instead of over. That seems to be a little bit better. I show it the opposite way here, so please excuse that.
As much as you can, like so, and you just want to wrap it around. Basically, you can see there are notches there, and then obviously with your bridge, and the bridge is meant to kind of go about halfway in between this thing. So you can see I have the strings in, and like so, and now we have to tune it. G, D, A, E. So thickest is G, D is second thickest, A, and E is the thinnest. One thing I recommend to do is to sand the pegs and the peg holes. You can see how that's like smoother compared to this. And these are printed, of course, solid, and they're printed this way instead of upright, so that way it can it doesn't flex.
One absolutely critical thing that I've mentioned again is you must rosin the pegs. You need some kind of thing to make them grippy. Otherwise, it's just not going to work or work very well. If what you want to do is you just want to rub your bow, the rosined bow, along the peg stem and get every part so they're very grippy.
So a tip for sanding is that you want a a rougher piece of sandpaper, a lower grit, and you want a higher grit, thinner. This one will buffer it, and this one will get rid of pieces.
This is your first time tuning a violin. It's a bit of a pain in the butt to get it in tune first. Actually, having micro tuners down here would be optimal if you can get any. Maybe I can try to make something. Otherwise, basically, if you want a digital tuner, or you want an instrument like a piano that you can tune it to, or like a tone generator or something, and of course it's G, D, A, E, but basically you tune this like that's about an F sharp, so it's just a semitone off. And I just what I've done is I've actually, for the thick wires, the two here, I've done it underneath, as you can see there, underneath, and then over for the thin ones. So we just have to tune this a tiny little bit like so, and it's a little bit too sharp, so we just adjust a tiny little bit away, and that's again not too flat. So you just kind of play around. So vaguely that's a good enough G, and then you go to the D, and we can see we're too flat for that. Basically you have to go from here to here to here to here, and then do it over and over again, because as you change the thin strings, your thicker strings will get out of tune, and you just have to keep redoing it like 10 times or so to get it right, and eventually it'll be in tune, because it's just a pain in the butt to do, but you just have to do it like at least once to get it fully set up. But just notice that you will make the other thick strings out of tune when you tune these ones, and you just have to go over it again, and slowly you'll kind of, that's the pain of not having fine tuners, but whatever. Okay, I have not played violin in a very long time, so we try to get it. I will spare you the sound of a dying cat. Essentially, I had to make some modifications, so it's very high up. I need to fix that. Yeah, it's too high. The strings are too high up. I'm gonna have to print a new bridge. Okay. When is this gonna work? It's like 2 hours later now, and I have, you can see the bridge is more like a real one. It's a little bit, there's not much room. I'm gonna have to make it a little smaller, I think, a little bit lower, probably, at least around this area, but it works. I guess. It's not that bad. It's not quite as, actually, compared to a real one, it's not that bad. So it's rattling, which means I'm gonna have to slightly raise the end, but I think that will be the end of it once I've done that, and now I can upload it. So That was no good. So yeah. Oops. I'm not as good as I used to be, but I hope that gives you a basic idea of how it works, you know. And then there's the so it does everything. It works pretty good. So stiff, can't do the vibratos very well. But anyway, that is comparing this to, here, hang on, let me go grab a real one and I'll show you the difference. So instantly, the thing I noticed on a real violin is it's very loud. Now the reason, but it's not too bad. This is a lot more resonant. This is a lot duller, but it has a lot more of a mellow kind of tone to it. The reason is because the F holes are a lot lower. They're not in the center, and the tone hole's a lot lower, and this is a lot thicker. If it was thinner, it would give more of a resonant tone, I think. But it's still pretty loud when you play. Like, it's loud enough. I used to use a mute when I would play it because it's too loud for me, you know. This one's a lot louder and it's a lot richer in tone, and the actual body is a lot more fit, I guess, and it's easier to play. The neck is smaller as well, which actually I don't mind. If anyone has an issue with the thickness of this, tell me, because I don't really, for me, my hands are very big. Oops. So for me, it's fine, I find. And you get enough lower range that it's fine. There are a few, like, you'll have to sand out some of these if you're gonna get to the lower regions, you know. Same way, you gotta be careful at the top. But hey, look, for the price of maybe $20 of filament, 1 kilo, this is about like 800 to 700 grams of filament, give or take. And then you gotta have the strings, you gotta have the rosin. You might need a tuner and a bow. It's, you know, this is a it was a $150 violin. It's a pretty cheap violin. It sounds nice for what it is. I think it plays nice. Testament to Chinese replications, but the point is, if you just want to see what one's like, you can see that it works, right? I hope that I'm trying to get that across. Like, it works. It's, you know, it's the same thing. You can also play it like a viol down here. If you can't see it, it's kind of like that, you know, like, for example. But you play it on your lap. The point is, it works, right? I hope I'm getting that across. Anyway, I'm gonna upload this and finish editing the video, and get yourself a free copy of this violin, because it's I don't know, it's cool, right? I think it's cool, at least. So I don't know.